Hey everybody, Bill Sky, the C++ guy, and this video is going to be all about some advanced functions. This is actually a follow-on to my previous functions video, but I threw arrays in between because we're going to talk about how functions can be used to do things with arrays as well, and I didn't want to teach that before I taught arrays. So if you haven't seen the introduction to functions, go 2 videos back, take a look at that. Take a look at the arrays function, the arrays video, and then you can watch this one. You'll get a full overview of what it's all about. But we're also going to talk about a thing called default values, overloaded functions, as well as global versus local variables. Global variables, horrible. But you can do it. And I'm not sure there's a company on the planet that would hire you if that's how you wrote your code, but it is a feature of C and C++. So let's get right to it. So I've got my C++ functions program up here. This is the same program that I used in the video on functions. And let's go ahead and extend it. Now, as you can see, I've got my cpp functions.cpp file here. That's my main function source file. But also I've got my functions CPP and my functions HPP. For those of you that haven't seen my functions video, I really suggest you go take a look at that because it's more than just functions. It's actually how to separate your functions into separate files so you can share those files or create object files. It's pretty cool actually. But anyway, those files they contain all of my functions. You can see right here, well, not all of them, but they contain a couple. There's the clear kin function, there's the calculate hyp, which is calculate hypotenuse functions. The HPP file has constants and function prototypes, and then the CPP file actually contains the function implementation. I don't know if we're going to do that today, but let's go ahead and get started here and talk about passing an array to a function. So to keep this simple, I'm going to create a very simple array here. And I'm just going to create an array of integers. Just an int array. I'm going to make it of size. Let's create a constant first. And we're just going to put that in there. All right. So there's my array. Now let's say if I want to write a function that's going to initialize that array. Let's say we're going to use that array, 5, 10, 20, a million times in my program, and I would like to zero it out. So what I'm going to do is I'm going to put my function up above here, above main, just to make it easy to see. And that function is going to return nothing. So we're going to say void, and we're just going to call this init integer array. Now I need to send arguments to that function because I need to send the array to that function, and I need to send also how big the array is. If you notice, this integer constant is located only inside of my main, so it is not available to the init integer array function. Now I could cheat a little bit. I could go ahead and put it up here. Now it would be available, but that's really not how you do things, because what if somebody wants to use your init integer array function and they don't use global variables? So it's really not a good idea to do that. I mean, you could do it to get over it, but to get it done, but it's not really the way they do it. So normally what you'll do is you'll pass the size of the array. So we're going to say size of array as an integer, so that's going to be the first argument. And then the second argument is going to be an integer array. So we're going to say int the array. And we're just going to put open and close brackets, square brackets. We're not going to put any number in there. You don't want to do that because you're going to use the size of the array to keep track of how big that array is. All right, so how do we process that array? Well, let's use a for loop. So I'm going to say for int I equals 0, I less than size of array I plus plus, and we're just going to say the array of I equals 0. So that's all that function is going to do. Is it's just going to zero out all of the items in the array. I mean, it's really that simple. Now, in my videos, I haven't really talked about two-dimensional arrays yet, but a two-dimensional array can also be sent to a function. I'm going to talk about that in another video, because what I'm going to do is I'm going to combine the discussion of two-dimensional arrays with how you would pass them in a function. And it's not really that difficult, but it's just kind of strange. There's some different rules there. For an assembler language programmer or somebody who's been doing this for years, it's not that strange. But for somebody new, I can see it would be pretty strange. So you don't want to put a number in there. If you put a number in there like 60, even though that array is only a size 10, it's going to cause a problem. It compiles okay, but that doesn't mean it's going to work. So you don't want to allocate, you just want to leave it blank and just say, hey, that array. And let's go ahead and then run that. So I'm going to say init integer array, and I'm going to send the size, and I'm going to send the array. And that's it. So that will initialize the array. Now it's interesting you don't put square brackets when you call the function, because an array is actually a pointer to the first item in the array. Oh my God, what does that mean? The variable in int array is actually a variable that contains the address of where our first item in the array is located. Whoa, that's just how it is. I don't necessarily like it that way, but as an assembly language programmer, it makes complete sense to me. As a machine coder, it makes complete sense that they would do that. If you wonder what I'm talking about, if you just say count or cout and int array with no square brackets, let's see what it outputs. And let's make sure. Okay, I do have a warning down here. What was that? Oh yeah, that was the one we just put in there. So let's go ahead and run that. And here you go. So this is the address of the first item in the array. Array square bracket 0 square bracket. Yeah, weird, right? But that's how everything works in a computer program, is that everything is based on memory addresses. Even on your hard drive or your SSD, there's an address. You know, there's like a chip row column or whatever it is for SSDs. For hard drives, there's a cylinder, there's a track, there's a sector. There's got to be some address, and that array, the very first item in the array, is stored there. Now for an integer is normally 4 bytes, right? So the next item in the array would be at that address. Instead of 0 at the end, it would be a 4, because an integer is 4 bytes. So it's literally an address. And so when you send the array name to the function, you're just telling it, here's the address. Here is the address of my array. It puts it in this variable name within the function called the array, and the square brackets tells the compiler, oh, that is a pointer to an integer array and not just an integer. Now, if you don't know what pointers are and you're very, very curious, take a look at my advanced C++ video on pointers. It'll go through all of this. I think it's a pretty good video, actually. But so that's really, and that's how you do it. So you just specify the array name with no brackets when you call the function, and you put empty brackets when you receive the array in the function itself. Now, one other comment I do want to make about this is that arrays are automatically passed to a function as passed by reference. So it is not copying the array here. It is actually sending it, passing it by reference. If you remember, if you watch that video, my video on functions, if you put an ampersand in front of a variable name, that means it's not going to pass it by value, which is copying the value to that variable in the function. It sends the real value. It sends the real variable. Well, with arrays, and this is what can be confusing, with arrays you don't need that ampersand. And it always sends it passed by reference. So if you make changes to it, it'll always make changes to the original. And we can make another function. I would like to just create another function maybe here called print. And just saying that, I would say cout. Pretty easy, huh? So you can copy and paste it. This is just normally how you do things with arrays when you send them to functions. Okay, now the next thing I would like to talk about is I would like to talk about default values. I have a function right here called, where is that little guy? There it is right there. Calculate hypotenuse side A comma side B. What if I call that function like this? Is that possible? Well, if we go back to the function, it is not possible because we have two arguments in the parentheses, not just one. However, there is a thing called default values, which personally I absolutely detest. I'm probably going to get some messages from people that know this, that know default values, and say I'm full of beans. That's fine. But I just really detest them. And the reason I detest them is because it can cause trouble. And what a default value means is that you give the user the option of specifying a value or not. And the way that you do that, and you always have to start from the right to the left. You can never start from the left to the right when you do this. In other words, I can't make this one a default and this one not. The first default value must always come from the far right. So if I want to make the B side of the triangle, in this case, a default value of 1, I can just say equals 1. That means when the user calls the function without the second argument, which would be the B side, side B, it's going to automatically make it a value of 1 in the function. Now you have to do that in the function header, or in the function definition line itself, and you also have to do it in any prototype that you might have for that function. So let's go ahead and save. Let's go back to the main and make sure we've got it. Yep, let's build it, and it should be fine. Oh, wait a minute. Oh, it looks like it doesn't want us to do that in the... It doesn't look like it wants us to do that in the CPP file. So let's go ahead and take it out of the CPP file. Save and build it, see if the compiler is going to be okay with that now. Right, it's kind of interesting. The HPP file, you've got to put it in there, but you can't put it in the CPP file. I don't know why. So they want you to put it only in the prototype of the function, or if you put the function like we did up here with print integer array in there. So it can only be in the first definition of the function, either the prototype or the actual function itself. It can't be in both places. Kind of weird. So I'm going to go ahead and run this. So let me see. So, okay, so let's do the first one. Okay, yeah, let's go ahead and do the first one. I'm going to move this down. Instead of saying side C, I'm just going to say C out. And let's see what we get when we run this. Now, so side A will be 10, and side B, since we didn't specify it, that'll be 1. So what would the hypotenuse be for that? Let's put in our numbers. It's 10.0499. We can go into the HPP file. We can change that to a 2. Now when the user or the programmer just calls that function without a second argument, it's no longer 10.0449. It is now 10.198. So side B is not specified when we call the function, but it is specified as a default value in the HPP. Now, something else that you can do is you can make all of the variables going to a function to be a default value. I'm going to make that equal to 5. Now, if I do that, I can actually call this function like this without the 10, without any arguments. And what that is going to do, whoops, I got 2 semicolons. Actually, I find it interesting. It's telling me that I do have a problem here. Let me go ahead and save and build this. See if the problem went away. It says warning. Let's see what this problem is. It's not telling you there's anything wrong in my main, but let's take a look at the CPP. Let's take a look at the HPP. Okay, looks good. It says here invalid arguments. Candidates are double, calculate height, double, double. So I can't get rid of all of my default values, or I can't get rid of all of my variables that are being sent to a function. I need to specify at least one. And the output's kind of interesting because I don't actually see an error. I'm seeing warnings and it seemed to link okay. That's kind of interesting. So let's go ahead and run this and see what we get. Oh, it's running. And the number's different. So yeah, I find it interesting that the Eclipse parser is saying that there's a problem here, but there actually isn't. And how did I know that? Well, I'm going to go up to Project and Clean. And then I'm going to say Project Build All. Let's see if that problem still exists. Yeah, the compiler, and this is really where you need to look here. The compiler is saying that there's an issue, but it's something completely different. Yeah, I find this pretty interesting. It has something to do with an int array. So I'm not really sure what's happening there. But yeah, so an Eclipse is telling you there's a problem here. A lot of IDEs do that. They have an indexing for that language, and if the compiler allows something, maybe the indexing for that IDE isn't seeing it the same. So you definitely want to look at what the compiler is saying, and instead of actually looking at what Eclipse is saying. So those are default values. Now something that you cannot do is I can't do this. I can't say I want to make the first one default and the second one 10. You can't do that at all. Let's save and build that, and we should actually get an error from the compiler down here, which we did right there. So you can't skip the first. So that's why I said earlier, you always start from the right in the arguments list. In your prototype, you always start from the right. You make that one default first, and then you can make that one default. You can't do this. You can't make the first one have a default value, which means it can be left out, and then the second one can't have a default value. It's just a rule. You cannot do that. So it must always go from right to left. And in this case, it's letting me do them all as default values, even though Eclipse is saying there's a little bit of a problem there. So I can specify both of them. I can specify the last one or the second one, or I cannot specify the second one, or I cannot specify both of them. So those are default values. You might want to play around with it. I dislike those immensely because it's kind of like, okay, where's the function going to happen? And this brings up a good topic as to why, the next thing I'm going to talk about is why default values can be confusing. What if I have a function here, and let's go up here to our HPP file. What if I have a function here called calculate height, and I have another one called calculate height? Can I do that? Can I have two functions with the same names? You certainly can. Those are called overloaded functions. And they have the same name, but they've got different arguments being sent to them. So I can't send a double-double to calculate height, the new one, but I can send an int A, int B if I'd like. Now, the variable names don't matter. Those can be exactly the same as the other function, but the data type is different. So I can create a calculate height that looks like that. I can create a calculate height that looks like this. As long as the argument data types are different in any combination, then it's okay. You can do this as many times as you want. Now this is really a bad set of examples, but this will actually work. And why do we do it that way? Well, because you don't want to write program functions, reusable functions, and that's what functions are for, right? They're to be reused. You don't want to have reusable functions that only allow the user to type in specific data types. You want to make it as flexible as possible. So what you do is you create the same function name and give it different data types, and then each one of those functions processes those data types differently. So those are in our HPP file. Now I have to go into my CPP file and I have to implement them. And I'm not going to implement all of these, but I do want to get it to the point where it compiles. And I think we're going to get a bunch of warnings because we're not actually doing any returns there of doubles. But it did compile. But we got a bunch of warnings. And you do want to take care of warnings. Warnings are not, warnings because the compiler is in a bad mood. Warnings are there to tell you that there could be a possible problem. So overloaded functions is a function with the same name as another function but takes different arguments, and those different arguments are data type differences, not the variable name within the argument list. Also, it doesn't matter if whatever the data type is. So for instance, if I did this, if I said int calculate height int a int b, the fact that this is an integer but these are the same arguments as these, that doesn't matter. This is going to get a compile error. It's going to say, wait a minute, you already have a calculate height that takes 2 integers, and I don't care what it's returning. I'm only looking at the arguments inside the parentheses. Now, I don't know if this is going to give me a compiler error. Yep, it certainly did. So in this case, it said calculate height that takes 2 integers has already been defined up here. And it says it here, error, ambiguity, new declaration of integer, calculate height, int. And I know that's a little bit confusing because it was double there. It's not looking at the return type. It's only looking at the function name and the arguments that go in there. So you can see how this could be kind of confusing, right? When you're talking about default values. Here's a double. Can I create another one? Can I say double calculate height double A double B? Can I do that without default values? Let's see. Yep, it's letting me do it. Whoa, this is getting really confusing. So if I call calculate height and I give it 2 doubles, which one is it going to call? If I say calculate height and I only give it 1 double, let's say only this double right there, okay, I think it's going to call this one. So this can get really, really confusing, especially when you're dealing with overloaded functions. So again, default values I really dislike. Overloaded functions are very, very useful. I've coded many of them. And again, the primary reason is so you can have the same function name and allow different data types to go into that function and get calculated the same or maybe different. It depends upon the programmer and what actually you're trying to accomplish. And the last thing I wanted to talk about in this video are global variables. Now, if you remember when I first talked about that in the very intro of this video, I put my finger down my throat trying to, and that's because global variables, they are absolutely horrible. And the reason that they're horrible is because it causes so many possible problems in your program when you're trying to debug a problem. And so let me show you what a global variable looks like. Now, here we've got our main program right here. And I'm going to create a global variable. Now, you don't have to specify the keyword global or anything like that. You just put it outside of any open and close brace. So I'm going to say int some global variable equals 0. I'm going to save and build that, make sure it builds okay. Now, what this means, this variable right here, is I can access it in any function. I can say cout some global variable. I can do that there. I can do that there. I can do it here if I want. It's available globally. It's available to everybody. Now, it's not going to be available to any of the functions in a separate CPP and HPP file because it wasn't defined there. It was defined in the main program. And it's really, 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 really a bad idea to do that. And that's because if this variable is changed, and that changing of the value of that variable causes a program problem, where do you go? Where do you go to find where it was changed? You could have programs with hundreds of functions within them, and all 100 of those functions have modified that variable because it's global. Which one do you look at? Oh, it's a nightmare. Take it from somebody who coded before we had local only variables. We had nothing but global variables. It was a nightmare to debug. But ever since they created scope, where a variable is only available within the open and closed curly brace, things are a lot easier because some global variable, in this case, if that was the name of it, if it was not global, that was only modified at specific locations. So it's really a bad idea to use global variables. Now, I can make it even worse. So I'm going to make this global variable 100. What I can do is within init integer array, and I can do this in any function, I can create another variable name with the exact same name. Now, which one is it going to use? Is it going to use the global variable name, or is it going to use the local? Well, you've probably guessed right. It's going to use the local one. But first of all, why would you name two variables exactly the same? I mean, I can understand something like a counter like I or J. Those are very commonly used as for loop counters. But something like this, I know, first of all, some global variable is a stupid variable name. But why would you do that? All you're doing is creating confusion in your code as to what is what. And if I actually ran this, I think we would see the number 200 printed, which we did. Now the number 100 printed was down here when we couted some global variable. Now the reason why the global variable was counted with the value of 100 instead of 200 is because this variable was only available within the init integer array function. So that's the only place it was created, and it goes away when that function is done. So the main printed some global variable from the global variable itself. I hope you're beginning to see some confusion already. Which one is going to be used, which one is not going to be used. Really good idea to stay away from global variables. So that's the end of this video. We talked about sending an array to a function where you specify the array name and the size of the array as a second argument. We showed you how to display the address of an array, and we talked about how an array is actually a pointer to the data in memory that is stored in that array. We talked about default valued functions, which, as you have probably figured out, I don't like, but they are available to you. We talked about overloaded functions. Remember, an overloaded function is a function that has the same name as another function, but different argument data types. Not different argument variable names, but different argument data types, and it doesn't matter what the return type is. It only looks at the data types in the argument list. And then we talked about global versus local variables. We talked about how horrible global variables are, how confusing it can get, how if you create a local variable in a function with the same name as the global variable, it overtakes it. It doesn't modify the global variable, but it uses it within the function instead of the global variable. Crazy, right? So stay away from global variables. Use default values if you find them useful. I don't think they very well self-document. And I hope to see you at our next video.